Okay, for the volume of a sphere, this is your lesson, and what you need to know first, this is a sphere. It's kind of drawn to look three-dimensional, and here is a sphere inside of a cylinder, and if you were to take all of the contents in the sphere and pour it into that same cylinder, it would go about 2/3 of the way full. So that has partly a little bit to do with what our formula is. So our formula, well, it has everything to do with it actually, but our formula is volume of a sphere equals 4/3, and I'm going to show you how to put that in your calculator. So 4/3 is the fraction, times pi r, not squared, but cubed. So this is different than what you've learned in the past with circles. Circles are flat, two-dimensional, and spheres are three-dimensional. So for that reason, the formula for finding the volume of a sphere is 4/3 pi r cubed, and these all get multiplied together. And remember, order of operations tells us to do exponents first. So I kind of wish this one would have come first. I wish it was r cubed times 4/3 pi, but you'll just have to know that you have to solve it with exponents first and then go back and multiply by the two other things. So here's your first example. The radius is the halfway across the sphere. So the whole thing is the diameter. We don't want that. We want the radius. We want halfway across. So our radius is 2.1. So if our radius, which is the r, is 2.1, we're going to cube it first. So 2.1 cubed times 4/3 times pi. Okay, and then it says round your answer to the nearest tenth. So we're going to get to just push the pi button. All right, let me show you about 2.1 to the third power. You have a couple of options here. You could either do 2.1 times 2.1 times 2.1, and that is obviously the same thing as 2.1 cubed. Or if you don't want to push 2.1 times 2.1 times 2.1, you could do this on a calculator like this one. You could do 2.1, and then you could find this button that looks like a caret key. It's like the top of a house, and that is going to be what power you want to put this to. So I'm going to push that button, and it looks like this so far, and then I'm going to push a 3. And that means to the third power. So 2.1 to the third power is a little bit, I think, easier than pushing it a lot of times, 2.1 times 2.1 times 2.1. And we get the same answer. So 9.261, but we're not done with that. After we cube it, we need to multiply by 4/3 and by pi. So here's how to multiply by 4/3. So I'm going to push times. And then 4/3 on a calculator like this, you're going to need to find the ABC button, which is a fraction button. So to do 4/3 on this calculator, I'm going to do 4 ABC 3. And it looks like this. It's got that little kind of like, almost like a comma, except what that is saying it's a fraction, 4/3. And then we need to multiply by pi. So I push times. And then I need to find, on my calculator, the pi button is right here. It looks like this. So times pi. Now that we've got all of it in there, I'm going to push equals, and we've got a really long number, but we are rounding to the nearest tenth. So that means one number after the decimal. So it's going to be 38.7, except for that the 9 is going to actually bump this 7 up to an 8. So 38.8. So 38.8, and because it's a three-dimensional sphere, it's going to be cubed. The volume is going to be cubed. So centimeters, cubic centimeters, or centimeters cubed. So again, this is really just a simple formula. Just whatever your radius is, cube it, times 4/3 times pi, and that is it every single time. So let's look at example 2. Example 2 is a little bit different in that it tells us the entire diameter. Remember, we don't want the diameter, we just want the radius, which is halfway across. So if the whole diameter is 7 and I only need half of that, I'm going to do 7 divided by 2 in my calculator to get half of it, which is 3.5. So I know that the just radius is 3.5. So here's my formula. 3.5 cubed times 4/3 times pi. And that is it. You're just going to put it in your calculator. So 3.5, and I'm going to do cubed by pushing this little caret key again. Cubed equals times 4/3, which is 4ABC3, times pi button. And it's as simple as that. 179.5, but the 9's going to bump that 5 up to a 6. So 179.6. 179.6 cubic centimeters. All right, let's look at our word problem. It says that soccer balls come in several different sizes. One soccer ball has a diameter of 22. Let's remember that a diameter is all the way across. Centimeters. What is the volume of this soccer ball round to the nearest tenth? And this time it's telling us use 3.14 for pi. So instead of pushing the pi button this time, I'm actually going to I'm going to type in my calculator 3.14. So if the diameter is 22, I need half of it. So I can go in my calculator and divide by 2. Or if you can do that in your head, half of 22 is 11. So we are going to take 11 cubed times 4/3 times not the pi button this time, but 3.14. And that's it. So 11 cubed is 11 to the third power times 4ABC3 times 3.14 instead of pi, 5,572 the 5 is going to bump that 4 up to a 5. So 5572.5. 5572.5, and that is cubic centimeters, round to the nearest tenth. Okay, and then the last one that we're going to do for our lesson today is talking about the diameter of a basketball. So again, diameter is all the way across. So it says the diameter is about 1.1 times that of a soccer ball, which we just found. The diameter of a tennis ball is about 0.3 times that of a soccer ball. So how do the volumes of these compare to that of a soccer ball, and explain? So let's see. The diameter of a tennis ball. Okay, so if the diameter of a basketball is 1.1 times that of a soccer ball, I'm going to go back up to my soccer ball, and if it says the diameter of a basketball is 1.1 times the diameter of a soccer ball, which we said is 22. I'm going to take my 22 and multiply by 1.1 to get my basketball diameter. So 22 times 1.1 is going to be 24.2. So what we're saying is if this is a basketball, my diameter of a basketball would be 24.2. That's the whole diameter. That's not the radius. And then it's also 0.3 times that of this is a tennis ball. Let me draw a little tennis ball here too. Tennis ball now is 0.3 times a soccer ball. So again, our soccer ball was 22. This time we're going to multiply by 0.3 to find the tennis ball's diameter. So 22 times 0.3 is 6.6. So a tennis ball is 6.6. And remember, these are the diameters. So if it wants to know how the volumes of these two compare to the soccer ball, we're going to have to find the volumes. So I'm going to start with the basketball. So I'm going to call that B. So for my basketball, we're going to take half of 24.2. And if you don't know what that is, just take your calculator and divide by 2. So 24.2 divided in half, which means divided by 2, is 12.1. So we're going to use 12.1, and we're going to do 12.1 cubed times 4/3 times pi. It didn't tell us to use 3.14, so I'm going to just push the pi button. So 12.1 cubed times, we'll go ahead and push equals, I don't think it matters, times 4ABC3, 4/3, times pi button is 7,420.7. That 9 is going to bump up the 6 to a 7. So 7,420.7. 7,420.7. This is how many, what did they say it is? It must be centimeters because that's what the other one is. That's how many cubic centimeters a basketball is. Okay, now let's come over here and do a tennis ball. So a tennis ball, we have the whole diameter, it's 6.6, but we need half of that to do our radius. So 6.6 divided in half, 6.6 divided by 2 is 3.3. So we're going to use 3.3 for our radius. So we're going to take 3.3 cubed times 4/3 times pi button, and let's see what we get here. So 3.3 to the third power equals times 4/3 times pi, 150.5. The 3 will not bump up the 5, so 150.5. So 150.5 cubic centimeters is our tennis ball. All right, now let's look at the final question now that we have all of our volumes. It says, how do the volumes of the basketball and the tennis ball compare to the one we found earlier, which was the soccer ball? So, I mean, obviously the basketball is bigger and the tennis ball is smaller, but I think it wants to know more specifically. So I'm going to take this number and divide by this number to see specifically how many times bigger it is. So I'm going to do 7420.7 divided by my soccer ball, which is 5572.5. And if I divide that, it is a little bit bigger than 1 time bigger. It's like 1 1/3, 1.3 about times bigger. So the basketball, I'll just write this out to the side. The basketball is about 1.3, and that was rounded. Remember, it was 1.3 something. So I said about 1.3 times bigger. And what I should have written, now that I've already written this and I'm almost out of room, is the basketball's volume. So technically, it's not just the basketball, it's the inside, the space inside. The basketball's volume is about 1.3 times bigger. And let's talk about the tennis ball. The tennis ball's volume is about, we know it's going to be smaller. Let's see how much smaller it is. So we're going to, when you're dividing, you always take your bigger number first. And obviously, this one is bigger than this one. So I'm going to take 5572.5, and I'm going to divide it by our tennis ball, which is 150.5. 150.5 equals, oh man, our soccer ball has a volume of about 37 times more. So the tennis ball's volume, we could go ahead and say, is about 37 times less than a soccer ball. Okay, and that is a very good comparison of the 3 volumes.